and making our sketches. And then once we learned and got confident with making sketches based on an equation, we're now going to take some information about an ellipse and then write the equation of it. So things that are important when talking about equations of ellipses is when the center's at HK, first and foremost, you have to know that these are the standard equations that we've been working with. So the horizontal case versus the vertical case. We have to know what A, B, and C represents. So I'll kind of list that for you here. A is the distance from the center to the vertex. And then distance from center to would carry over for B and C as well. B is center to end of minor axis. C is center to the focus points. Okay, a couple of other key notes here is that A squared equals B squared plus C squared. I don't know if I have it coming up, but just remember A has to be the largest value, especially according to this formula here. That helps me to determine horizontal versus vertical. The LR has a length of 2B squared over A. And then just some other quick facts that will certainly come up and maybe not as important to us when we're making sketches, but the length of the major axis has a total length of 2A. It goes from one vertex to the other, from B to B prime. And the length of the minor axis would go from B to B prime, and that would have a length of 2B. So what we're going to see in some of the given today is that we'll know the length of the major axis, or we'll know the length of the minor axis, and we'll be able to find A or B based on that. So that brings us to the question, what is the information that we need in order to write the equation of an ellipse? If you think about what we did with parabolas way back when, what did we need? We needed the value of A, so we could plug it in for 4A. We needed to know the vertex, and then we also needed to know which way the parabola opened. Well, we sort of need three somewhat similar pieces of info when writing the equation of an ellipse. Here's what we need. We need to know the center, which is similar to knowing, let's say, the vertex of a parabola. We need to know the values of A and B. Now, keep in mind, knowing A and B, we're then going to square those to plug them into the equation. And then lastly, we need to know, is it a horizontal ellipse or a vertical ellipse? This way we know where A and B should go. Should they go under the X's or should they go under the Y's? So we'll get some practice together right now. And then towards the end, I'll probably even give you some examples for you to try quickly on your own. So let's go ahead and take a look right away here at example number 1. So example 1, what are we given? We're given one vertex coordinate and we're given the two foci. So the vertex that we're given is at 6, 3. So go ahead and plot that. And there's really not a requirement that you need a grid to do this question, but I think it is nice to have it there for you, so that this way we can visualize some things like which way is the major axis going? Is it horizontal or is it vertical? Things like that. So the foci, it doesn't matter which one's F and which one's F prime. Okay, but I'll put those labels there for us. And I'm hoping one thing you would be able to determine is that if we need to know the center to write the equation, the center is going to be midway in between the foci, which in this case is the coordinate 0, 3. So we should be able to identify that point pretty easily. From there, what else can I determine at this point? Well, the distance from the center to the vertex, which has a length of 6, that's the value of A. Okay, we got to be pretty confident with that. We've used that for sketching over the past few days, so I know that A is 6. So now I want to talk about, well, what's the distance from the center to the focus? What does that represent? And in our key info we listed on the front page, we know that that's the length of C. So C is going to have a length of 4. So remember that we need to find the value of B, because in the equation we have A squared and B squared in the denominators. So I know A, I know the length of C. Man, I really wish I knew a way to get the value of B. Oh, wait, we know this to be true, that A squared equals B squared plus C squared. So when in doubt, if you don't know A or B, it's probably going to be that you're going to use this Pythagorean relationship that exists in an ellipse, and you're going to plug in what we know. So this is going to be a 36 here, right? 6 squared equals B squared plus 16. Subtract the 16 over to get B squared equals 20. Now I realize that that means that B equals the square root of 20. But remember, we actually aren't even concerned about what A and B are. we really want to know what a squared and b squared equal, because that's what's going to get plugged into the denominators. So although you could write b equals radical 20, you're just going to square it again anyway to put it into the equation. So I'm going to leave it as b squared equals. The last thing we have to consider is this a major axis that's horizontal or a major axis that's vertical? Because that's going to tell me where a squared and b squared are located. Based on the fact that the foci go left and right, and the vertex is also to the right of the center, the major axis for this particular ellipse is horizontal. It's going left and right, which means that the larger of these two numbers, a squared, has to go underneath the x's. So when I put all of the pieces together, the center, a squared, b squared, and the horizontal nature here, we're going to get, if you want to write x minus 0 squared, that's fine. You'd probably just see me write that as x squared, though, over a squared, 36, plus, now I'm going to use the y coordinate of the center, y minus 3 squared over b squared, 20, equals, don't forget, in standard form, an ellipse is equal to 1. And that is the equation given that one vertex and then the two foci. All right, so that's what it looks like putting all these pieces together. We're going to see some other types of given information that will help us to come up with some equations here. Moving on to the next example, we've got vertices at -1, 3, and then also 5, 3. So let's plot those. And I'll apologize that the grid lines that I have actually are pretty faint here. So if they come out pretty faint, if you wind up printing this from the post that I give you in the blank copy, it doesn't, you can use real graph paper if you want to. It's really not a big deal. All right, so we've got our vertices v and v prime. The length of the minor axis is 4. Okay, that's going to help me, but it doesn't really give me specific points on here that I'm going to use to plot. Now, just like in the last example, how the center was midway in between the foci, the center is also midway in between the vertices. So there's my center coordinate right there. The center coordinate is going to be, let's see, midway in between -1 and 5 should be the point x equals 2, 3. And because the vertices go left and right, I know that the major axis is horizontal. Even beyond knowing the major axis is horizontal, we saw in the last example that distance from center to vertex is the length of a. So in this case, a equals 3, which gives me that a squared is 9. So we'll use that when we go to write our equation. The last thing that we're missing from this whole puzzle is, well, we know the center, we know the major axis, we know a squared, we need to know b squared. We're going to get the value of b squared from this last piece of info. If the length of the minor axis is 4, this connects b to b prime. So think about that connection from b to b prime. It's going to have a total length of 2b. Okay, so what that would mean is that would go up 2 and I would go down 2 to get that total length of 4. So if 2b has a length of 4, the value of b is 2. And if b is 2, that gives you that b squared is actually back to 4 again. Okay, so be a little bit careful there, right? Because doubling this and squaring the number 2 get you the same number, which is just kind of coincidental. Okay, but we now know a squared and b squared. We know it's horizontal again. So here's my equation. X minus 2 squared. Horizontal, bigger numbers under the x's. Plus y minus 3 squared over 4 equals 1. And that's pretty much the process. If you can identify center, AB, and then which way the major's going, you've got all the pieces. Sorry, that one was not as colorful as this one up here. All right, let's keep going. Okay, on the next page, I'm going to do 3 and 5 with you. After we're done with 3 and 5, you guys are going to go try 4 and 6. How about that? Okay, so number 3. We know that the vertices are at -5, 0 and +5, 0. Okay, v and v prime. And that the length of the LR is 8/5. Okay, so given the two vertices, we definitely know the center is midway in between. It's kind of nice in this case because the center is at the origin, which is convenient for us. Because the vertices go left and right, oh boy, I hope we get one that has a major axis that's horizontal, but or sorry, I mean vertical. This one's horizontal again. All right. They won't all be horizontal, so don't default to that always. But all right, we've got the center. We know it's horizontal. We know the value of A again. That's kind of nice. A is the distance from center to vertex. So in this case, A is equal to 5, which means A squared is 25. We're going to eventually need the value of B. And in order to do that, we're going to, of course, use that last piece of given information. So the LR has a length of 8/5. Here's where knowing the formula for LR is going to really come into play. So the LR length is in general 2B squared over A. That has to equal 8/5. Okay, now remember that we know the value of A already. We know that A is 5, so I can plug in 5 for A, and then I can solve for B. So this would be like saying 2B squared over 5 equals 8/5. Now I can certainly cross multiply and solve this equation for B pretty easily, but I'm hoping that you're seeing is that since both denominators are 5, you can actually just set those numerators equal and solve pretty easily for B there. So if 2B squared equals 8, you're going to get that B squared equals 4, and maybe I'll stop there because I know that means B equals 2. But in this case, we have to plug in B squared anyway for the denominator. Okay, center's at the origin, horizontal. Here's A squared, B squared. So it's going to be X squared over the bigger number, which is 25, plus Y squared over the B squared, which is 4, equals 1, and we're done. How about that as a little catchphrase so you don't forget it? Equals 1, and then you're done. Because that could be something that we kind of easily forget through the process there. All right, I promised you one more. Let's take a look at number 5. So we take a look at number 5. We've got those two foci, and we know the length of the major axis. Okay, so the foci, to be honest, guys, I'm not going to even spend my time counting up 8 and down 8. I'm just going to approximate, try and make it look even. Here's F, and here's F prime. It's really common, by the way, for students to make a mistake and actually look at these coordinates and go left and right those distances. So just be careful. 0, 8 goes up, 0, negative 8 goes down. All right. I like it when the center is right at the origin. Makes our job just a little bit easier when you write the equation. The center is at 0, 0. And based on the location of the foci, I do know which way the major axis goes. And I know what you're saying out there. Finally, we get a major axis that's vertical because the foci go up and down. The foci are on the major axis. They're in line with the vertices. So if I knew where the vertices were, they would be going up and down as well. Okay, we definitely know the major is vertical. We know that the distance from center to focus is a length of 8. Remember that that's the value of little c. We know that little c is the length of 8. Okay, so that doesn't get me A and B quite yet until I look back to this information where the length of the major axis is 34. Okay, major axis goes from V to V prime all the way across. So what does that have a total length of from V to V prime? It has a total length of 2A. Okay, it's double whatever A is. So if 2 times A equals 34, that tells me that A is 17. So if I know A is 17, I'm going to use that relationship like we saw earlier. A squared equals B squared plus C squared. It's going to come up a lot, by the way, so don't forget about it. Okay, and I'm going to square these values. A squared would be 289. B squared, we don't know. C squared would be 64. You subtract 64 over, you get B squared equals 225. I'm going to stop there because I don't really need to know what B is, even though B is a nice number. B is 15. Okay, A squared happens to be that 289. So we've got a center. We know the major is vertical. We've got A squared, we've got B squared. Let's put it all together. It's going to be X squared over plus Y squared over equals 1, and then I'm done. Okay, I kind of purposefully left out the denominators because this is the first time you really have to think carefully about the bigger number has to go underneath the Y's. The major axis goes up and down. 289 should be under Y squared. 225 should be under X squared. And then I'm all done. Okay. All right. Go ahead and try 4 and 6. I'm going to show you the answers to those right now so you can check them out. And then that's it for today. You'll see some practice in ellipse number 3 posted on the website. Okay, here's the answer to number 4. You were given the two foci, so the center is midway in between at 0, 2. We know the distance C, center to focus, is 4. How did I know A was 5? Because the major axis has a length of 10. That's 2A, just like we saw in number 5. So A is 5, C is 4. Use that Pythagorean, A squared equals B squared plus C squared. This horizontal line I've drawn is to remind you, oh yeah, the major axis is horizontal in this one because of where the foci are. So bigger number has to go under the x's, smaller number goes under the y's. And last but not least, number 6. We've got, in this case, the center was given to us. We know where one focus and one vertex are located. Okay, so this focus was 5 units above. This vertex was 7 units below. Those are the values of A and C, as you can see I've written in there. So I found B squared by using the Pythagorean relationship. The major axis for this one is vertical because the focus and vertex are located above and below that center coordinate. So just make sure when you write the equation this time, the bigger number is under the y's, the smaller number B squared should be under the x's. And that's pretty much it. Okay, so if you have any questions, you'll let me know. But otherwise, go ahead and try ellipse homework 3. Talk to you guys soon.